All right, guys. So real quick, we're going to go over our continuity. Whoops, it's way over here. There we go. Sorry, guys. We're going to go over our continuity piece. Technology has been a battle today. So let's, I don't know why it's doing it this way. Let me move this. There we go. Let's go backwards. Okay, so if we're dealing, let's just kind of talk about it. So a point discontinuity is literally a point that's missing on the line. A jump discontinuity, we really don't need to worry about oscillating to. So a jump discontinuity is like going from here, like a piecewise graph, and then jumping to another spot. So that this is the jump. It like jumps. That's a jump discontinuity. An infinite discontinuity would be like your infinity ones here. So it would be the fact that it's approaching infinity right here, and there's a discontinuity because they don't ever touch. So those are the quick ideas of infinite discontinuities and different things. I've never really dealt with the fact that we needed. This thing keeps locking up on me with the oscillating ones. So you can check those out in your book for oscillating to kind of look them up. So what does determining continuity do for us? Basically, the whole idea is that continuity lets us determine how the equation is going to be utilized. So in other words, in basic calculus, continuity of a function is necessary for the things we're going to do with it. So if it's not continuous, we can't differentiate it. We can't integrate it. We can't do any of those things. And also, continuous functions have nice properties to them that make us make assumptions about it, make assumptions about limits and different things like that. So this is why we determine continuity. Okay, so now continuity in itself is not that big of a deal, but let's go ahead and review some old language. So little things like this, like when you see f of c, f of c just means that my x value is equal to c. So whenever I plug in c, that's what I'm looking for. Don't forget, like f of 4 is equal to some y value. So when I plug in an x, so this would be x equals 4, it's going to give me out some y value. That's what they're talking about in those types of things. Other than that, we already talked about as the limit approaches and stuff like that, but just watch the terminology on this. Just remember that this here is literally the input side, and this is the output side. Okay, so hopefully that helps you a little bit there. Let me move this up. All right, so there's 3 conditions that have to go, and you just do them in order. Number 1, when you plug in C or plug in X, it must exist. In other words, it must give you a Y value. It has to. I don't know where those went. That's very interesting. And then as the limit approaches C, that must exist. So we can't have discontinuity. So this cannot have, this says no discontinuity. None. So we got to find the limit. So first we got to plug it in. Second, we got to see if the limit is there. And then third, if the limit equals the Y value, then it's continuous. Okay. So let's kind of walk through one here. So we have is f of x plus equals x plus 1 continuous at 2. The first thing we do is we need to know if it exists at x equals 2. So we just plug it in. How do they get this? They say f of 2 is equal to 2 plus 1, which is equal to 3. So when I plug in 2, I get out 3. Now, the first thing we can do is check to see by plugging it in. Remember, you got 3 options for limits. You have plug it in, you have factor, and you have a graph. Does the limit exist at 2 for x plus 1. If we plug it in, yes, it equals 3. So since my f of 2 is equal to 3 and my limit is equal to 3, then yes, f of x plus 1 is continuous at each point. So all three have to happen, and I just do them in that order. It's much easier. So what happens when something doesn't work? So if we get to this one here, we start right off the bat. If I plug in 0, so f of 0 is equal to 1 over 0, that is undefined. It does not exist, and then no, it's not continuous at 0. Okay? So for every one of them, that's what we're working on. So if I work on this here, again, at 0, so I need to use the one, I need to use the one that allows me to use 0 for the first part. So f of 0 is equal to 0 plus 1, which is equal to 1. I can't use this one because it says less than 0, so this one I cannot use for that. So I get 1. And then if you graph this out, because plugging it in won't work, so this one's going to be a graph. If you graph this out, it shows you that it does not exist. Since 2 does not exist, then no, it is not continuous. So you have to show the steps like this for every single one of them. So, excuse me. Same thing for this one here. If I plug in, I want x equal to 2, so I'm going to use this one. So I plug in 2. 2 plus 2 is 4, so that gives me that one there. And then my limit as x approaches 2, does it exist? So if you graph this thing out, it is going to approach 4. And so since the input is the same as the limit, then we can say, yes, it is continuous at x equals 2. So each time we just keep doing the same thing over and over. This one here, here's one of those that f of 1 exists. So if I plug in 1, I get 5 out. I can't use this one because that cannot equal 1. So yes, it exists. It's actually equal to 5. And then if I look at my limit as it approaches 3, well, 3 is going to be this one right here. So if I factor that, I get x plus 2. So when I plug in 1, I get my value of 3 because it's going to be x minus 1 over x minus 1 times x plus 2. We're going to lose that, and we're going to get x plus 2, and that's where they get their 3 from because they're going to plug in their 1. But since 5 does not equal 3 or 3 does not equal 5, it cannot be continuous because they don't equal each other. So all three values, and I'll let you guys look at that one, all three values must match. Watch out for these piecewise ones because you got to utilize whichever one. So it's got to be equal to 4, so we got to use this one for the plug-in. Then we're going to see it exists as it approaches 4. So as it approaches 4, we could probably either graph it or we can look at it. And then this one, as it approaches 4, it's going to be 64. It probably comes from a graph. And since both of them equal each other, it is, yes, it is continuous. So that's how we're tackling it for